IBC workshop?
Hello, yeah.
Yes, it is. Welcome, welcome.
Let's go. Build some smart contracts.
Starting now. So guys, I think we can slowly start. Just gonna give a bit of an overview. So yeah, this is the fourth workshop, and yeah, we're gonna talk about IBC and CosmWasm, and in general, like how can we leverage these two things together. So just to put you in a perspective, like the whole CosmWasm and IBC interaction in general is relatively new in the sense that you could see around that there has not been a lot of games played with it, let's say like this. So there are some resources, but yeah, still like you can feel that there is way more things to be done. So, but yeah, in this workshop we basically giving first an intro. Wait, let me. Yeah. First, yeah, a bit of an introduction just to get everybody on the same page when it comes to IBC and CosmWasm. Then we're gonna look at few examples and seeing like how this can be used together. So yeah, we're gonna see some code and in general like see all the consideration that you will need to do in order to use IBC in your CosmWasm contracts. So yeah, let's start. So yeah, in general, IBC is really cool technology because it's basically what allows you to handle authentication and data transport of data packets between blockchains, basically. And this is extremely powerful because, as you probably already know, like yeah, the whole Cosmos ecosystem has been built with interoperability in mind, and IBC is an extremely important piece for it. And it's really cool now to see that more and more chains are adopting it, and also not only within the Cosmos ecosystem but also outside of it. So you really can see this becoming a standard for cross-chain communication. So IBC is a way of relaying these data packets in a permissionless way. So like in general, what this means is that the security of IBC just, I mean, it boils down to the security of the chains, right? In the sense that if you trust the chain you're receiving the packet from, then you won't have any problems with IBC. Like it's a trustless way of forwarding packets, right? You could take it as a Web 2 comparison as TCP. So. And in general, like using IBC like really enables this whole multi-chain vision, right? Where yeah, we have all these protocols interacting together. So an interesting thing to notice about it is that even if all the relayers were acting maliciously, then the worst thing that it could happen is that you get a denial of service attack, in the sense that like packets would simply get rejected. So because the cryptographic proofs that are broadcasted within the packet then like would not be valid, right? But like the even if liveness would be affected, in the sense that of course if you have all relayers that are malicious, then like the security wouldn't be affected, because still like if the proofs are not valid, then you know like your chain wouldn't perform any logic on the packet. So what this means is that even like in this case, in which let's say all relayers are malicious, then just setting up a relayer that is not malicious then would already solve the issue. So this is interesting thing to notice, in the sense that like you are not relying on any consensus mechanism when it comes to IBC packet transfers. Like if you have a relayer working then correctly, then you're set for good. So because this is a standard that is taking more and more traction, then I think it's interesting also to understand a bit like what are the layers within it, because there are a lot of standards that are popping up, and it can be confusing for folks, especially the ones that are coming from outside the Cosmos ecosystem, to understand how these whole things get glued together. So in general, you can think of different standards being worked on currently, and like in general, there are the basic infrastructure standards, let's say, that deals with the whole IBC transport, authentication, and ordering of packets. And these are, the standards of, setting up a relayer, having an IBC client, and how the overall IBC works. And also, there are other standards that are app specific in the sense that they are on a tech stack that is a bit upper the infrastructure of IBC. So, and this is where you would see a lot of other standards, like specifically for ICS and ICS 20, ICS 721. Sorry, yes, mouse just dropped. So yeah, and these are in general standards that are getting more and more into the place, and some of them started like a bit replicating the standards, the RC20, RC721 standards that are in Ethereum, for example. So just also a consideration that is important, I would say, or at least is interesting to do, is that in general, like when, for example, you're using IBC, then like it's the path that, for example, your tokens, if you are exchanging tokens through an IBC message, is relevant, is important, in the sense that, like, depending on the path that your token would go between a chain and another, then like is the token is like the IBC denomination of the token is defined by kind of a URL, is a path. So depending on the way that your token moves around the Cosmos ecosystem, then it would have a different path or another, right? So and this is important because it has to deal a lot with token fungibility. So there are some considerations that in general you would need to do when it comes to like using IBC. So, and also like sometimes most of the things you would like to do when it comes to use IBC in CosmWasm contracts, then like it would require you to instantiate the same contract, like deploy it in the two different chains you want to use it for. So we are gonna get into CosmWasm a bit. So for whoever doesn't know, like WASM is basically, it's a binary instruction format. So its whole purpose is to be like the compilation target for different programming languages. And this means that in general, like you could use different languages to create a WASM executable, but when it comes to CosmWasm at the moment, even if you could use Go, for example, the most recommended way would be to code in Rust. So it's highly advisable like to start learning Rust in order to create smart contracts with CosmWasm. And but the cool thing is that Area52 provides you with a lot of resources to do it. So for whoever is new here, then I highly recommend to just check out Area52, because it really gives you a sense on how to leverage CosmWasm to the maximum. And if you are new to Rust, then you can just learn Rust on the side, but then still like do a lot of progress with Area52, which for me it's amazing tutorial. So learning a lot myself. So yeah, and in general, like smart contracts in CosmWasm are like WASM bytes, and they are stored on chain, and they are connected to an identifier like a code ID, and then like after you store the code on chain, then you would instantiate it. So being instantiating the contract would basically imply that you get the contract address and you're ready to go, and having your CosmWasm contract deploy on chain. So yeah, and basically this allows you to, for example, use CosmWasm code to interact with different of the chains. That the chain should enable CosmWasm, of course. So just to give a sense of what would be the process is by the way, we reorganized the Archway docs, which there is the link later on the presentation, and I highly suggest to have a look for whoever missed the restyling and the reorganization. Also because in the coming week, we will be releasing a lot of CosmWasm documentation. So for whoever wants to get even more in the detail of understanding CosmWasm, understanding the difference with Solidity or other things, then like stay close, like keep an eye, because other than restructuring the whole Archway Docs website, we have been adding quite a bit of CosmWasm content and resources, and we will be keeping adding those. So like we aim at maintaining the CosmWasm documentation. So in general, like feel free to rely on the Archway docs, like to get all the CosmWasm information that you may want in order to develop your smart contracts. So so that's like what you would basically do when it comes to deploying a smart contract on Archway, and would be basically to create a new Archway project using the Archway CLI. So basically, when you use the command Archway, just for you to know, like what you're actually doing is just wrapping the Archway D, so the Archway daemon, and basically the Archway CLI is just a very thin wrapper of the Archway daemon, and we're actually also working on a whole modularization of the whole CLI. So like like that it can be used even in a more enhanced way with the Arch 3.js, and so just for you to know, like you would use the Archway CLI just to create the and build the contract, and you would configure it, and then you would build it, and basically like once you have built your contract with the proper configuration, and by the way, you can rely on some boilerplates examples. So like you will see that when you are actually using the Archway CLI, you can rely on some contracts that are already being created for you, that you can already try it out, and this is really cool because it gives you a really straightforward way, like to get your hands dirty on deploying smart contracts with CosmWasm. And in general, you will need to create the WASM file, so it would be cargo WASM, that's the command you would use. But after you created the WASM, then you would also need to optimize the WASM, and the reason for that is that when it comes to deploying, like to storing the contract on chain, you want to make sure that the contract that you're storing is doesn't have a lot of unnecessary data that you actually don't need, and like we really need to optimize in order to store it into the blockchain. So that's key. So that's why Archway built then uses the Rust optimizer to do it. So you would then store the contract, and which, as we say, that like you would upload the contract on chain, then you would instantiate the contract, so you would actually associate it to a contract address, and then you would basically set up the metadata that at the moment, just for you to know, it would allow you to set, for example, the owner address of the contract, the reward address of the contract, and this is key because actually is what makes you leverage to the full extent like the Archway module of rewards. So which is the way that developers can programmatically sustain their whole projects by harnessing the rewards that the network provides. So this is really cool, and this is the reason why it's useful to set up the metadata. So then what you would basically do would be interact with the contract. And by the way, when you instantiate the metadata, you would usually provide a flag with the arguments you want to add. So for example, if it's a simple counter contract, then you say, for example, what is the start of the counter, and then you would interact with the methods basically. So one very cool thing about CosmWasm is that like it has its own way of handling like its design has been built around the whole idea of actor model, that where basically CosmWasm messages are kind of shoot, and then but they don't you're not actually waiting for for a promise. Like you, basically messages are shoot. There are some operations that are getting dealt with, but then just the smart contract itself is responsible for its own state, and basically like this means that you are avoiding a lot of attack vectors, especially like the reentrancy attack vectors. That just to give a sense, was what damaged the DAO in 2016. So like that bug was actually something related to a reentrancy attack. And the cool thing about CosmWasm is that its wall design makes it extremely easy for you not to care about these things, because it's yeah, like the way that is built, like with its wall dispatching strategy, then it allows you not to be exposed to reentrancy attacks. So yeah, this is really cool. Like some people could argue that it's similar to having an automatic mutex over the entire contract code, and yeah, so it's CosmWasm is its own its own way of dealing so with with the processes. So yeah, it's really cool to see this. And in general, just to give you a sense of the flow, for example, you could have a contract A that reduces the token supply of the sender. So basically, like if you want to move some tokens from a chain A to a chain B with a smart contract, then yeah, you would reduce the token supply from the sender. You would kind of create an escrow of these tokens, and you would connect it to an IBC message ID, and then yeah, like the other data, such as the receiving chain and the sender. Then the contract would commit the state, and then it would also return a message to basically initiate the IBC transaction to chain B, and then this is where like the timeout concept gets into place, because you don't have the guarantee that the packet will be received or will be processed upon. Then basically you need to implement a timeout, which is what allows you to basically revert any state changes if the IBC message has not been properly processed on the other side. So yeah, after this, the IBC message gets basically validated, and if the IBC message is correctly validated, then the escrow are basically the escrow account gets deleted, and the tokens are successfully transferred to the chain B. And yeah, of course, like if there is any error, like the escrow like handles the tokens in the way that an escrow would do. So yeah, in general, like there are a few examples around on how to use CosmWasm and IBC. There are the resources that I've put, so like you can also look into those. And in general, just for you to know, like you could either use some like a standard that is already existing. For example, when you want to move tokens from a chain to another using CosmWasm, like you could use an already existing standard like the ICS20, or you could also implement custom standards within the protocol and within a smart contract. Sorry. So yeah, in general, just for you to know, like you will need to define like the channel, of course, that where you want to send, and the token to, and in general, like the timeout you will need to implement, basically, as we said. And this is, by the way, really similar to how the IBC transfer works within the Go module of, for example, the application specific chain. So like as you see, like these two methods, like the IBC transfer and the bank message send, are very similar. So like if you already played a bit with the Cosmos SDK stack, like you would see that there isn't much difference between these two methods. And in general, what you will need to do is that like you want to connect like you want to perform a channel connection. So you basically need to open a channel, right? Because that's like the way that IBC works is that you would have a channel connection open, and then you would have a relayer that forwards packets across this channel. So this basically means that you need to have a whole acknowledgement protocol, in the sense that I mean, you would have an opening. For example, if you want to connect two chains between them, you would have the chain A that says to chain B, hey, like I'm chain A, can you please verify that I am chain A, and can you please tell me who you are? And then you would have the open try, that where the chain B actually verifies the information, and then it would actually get back to the chain A with its own information. And basically, once the chain A verifies its engagement, it is ready to open the channel, and basically you would have the channel open. This means that you would actually need to expose 6 entry points in a CosmWasm contract in order to enable IBC communication. So if you want to perform, for example, IBC transactions by using CosmWasm within your own smart contract, then you would need, in general, to have the IBC channel open and entry point, and this would basically what would handle the open init and the open try that we saw before. Then you would have the IBC channel connect, and where you would handle the acknowledgement and also like the confirmation of that the handshake has been successful. You would have the IBC channel close, and then in this case, like, you would be able to handle the channel closure, and you would also have the IBC packet received in order to basically handle the case of receiving packets, and also like the IBC packet acknowledgement in order to basically perform the acknowledgement that an IBC packet has been received. And again, as I said before, like because you don't have the guarantee that a packet is correctly received and processed, then basically you would always need to also implement the message timeout. So you would need to have an entry point for that. So basically, once you have all these points, all these methods implemented, you can instantiate the contract, and then always consider that like IBC works very similar to the way that ports in computers work. So in general, you have this kind of route in which you have the channel, and you need to set up the path, let's say, for the destination chain. So there are a few examples around there, who's mostly on one, a simple one, but just for you to know, like there are some repositories that I think are very interesting to look into. One of them is this CosmWasm 20, and it's interesting because like, for example, in this case, it's this repository, like you would actually see a different standard than the ICS 20 standard, which is the standard that it is the one for to exchange tokens through IBC. And in this case, like, it's a CosmWasm 20 standard, where it's, even if you would be able to accept tokens and move them around, and you will not be able to mint coins, basically. So you can basically receive token, release them back to the original owner. You can perform some logic into it, but you are not yet allowed to minting tokens. The reason I say this is that this is a bit for people who are getting just in the Cosmos space. It can be confusing, because then you see a lot of standards, and it's may not be always clear to know which standard to use, and also there is constantly a lot of progress that is getting done in actually, making the whole standards guideline current. So, but yeah, just for you to know, this implies also that there are a lot of opportunities for devs that want to implement their own type of standards, and they want to just get whatever they want from the Cosmos stack and use it in the most effective way for them. So this is the cool thing about the Cosmos in general. And now one cool thing that we could see is that getting a bit into some highlights of the IBC counter contract, which basically it's a smart contract that when it gets prompted, you would basically trigger it on a chain, and then the smart contract would send a message to another chain. And the reason why this is possible is that, as we said before, you would have actually deployed the contract into different chains. So, for example, you can deploy a contract in Archway, and then the same contract into Axelar, and then you would basically be able to send the IBC transaction, incrementing the counter of this contract, and by pinging one contract in one chain and letting the other contract receive the IBC message and increment the counter in the state of the other chain's contract. So basically you trigger a transaction on a contract, the contract send an IBC transaction, and the smart contract on another chain updates its counter, and then you have a whole current state across the chains, and you perform the IBC transaction through CosmWasm, which is really cool. So also because I say it's there are some standards from the Cosmos ecosystem that are getting now used even beyond the Cosmos ecosystem. So while before it was this is a Cosmos thing and stuff like this, now you can already see other major chains that in theory have nothing to do with IBC, and they are implementing it either on side chains or they are finding a way to spin up an IBC client. And this is extremely powerful because for developers that are starting to get comfortable with knowing how IBC works, then you're basically in the middle of the multi-chain future, right? So this is also the reason why we are spending a bit of time of reminding what are the things about IBC. So in general, in this case, with this contract that now we are gonna see the code a bit, you would basically store and instantiate the contract on two chains, and then you could either, so here's the thing, right? Because if you wanted to create IBC transactions between two chains, need to have a relayer. So in this case, Archway is now running relayers for basically enabling channels for both Axelar and Osmosis. So for example, if you are now participating in the hackathon, which by the way, if you're not, I highly suggest you to do it, because it's we have this hackathon running on, and it's gonna last another month more or less. So you have time to also get your hands a bit more dirty with code, and also we are having office hours every week. So on Wednesday, there is 1 hour in which we are basically assisting devs that have issues with their smart contract, or simply need some explication or some support for developing on top of Archway. So just for you to know, we have these weekly initiatives where we support them, and also there is this hackathon that is running. So you are already in time to participate, and so it's wonderful opportunity to develop, especially because we also do our best to support anyone who joins the hackathon and has any issues. So I'm saying this in the sense that, for example, right now for Python, like there is no need like for you to spin your own relayer, so you would be basically using the relayers that we already have set up for acceleration and osmosis. But if for whatever reason, like you wanted to connect to another chain, then nothing prevents you from running your own relayer. So there is documentation out there. I've put some links also, like to reference to it. So really cool. But yeah, you don't need to do it in general. You can use the relayer that we have. So basically, you with this IBC counter smart contract, like in general, you would ping the increment method, and this is basically what you would would increment the counter in the smart contract, like updating its state, and then basically send the message to the other one, to the other contract in the other chain. And then you would have the get count method, where that basically it's a query where you can see like where the counter is, like, and here I put the repository where you can actually also get into some code and see how it goes. And also, like in general, you will need to instantiate the smart contract on one chain, and because then the packet would be relayed to chain B when again the contract gets triggered. And then, as we say, like the reason we also spend some time on explaining a bit IBC is that you will need to take into consideration the whole how the whole IBC works in order to use IBC with CosmWasm. So you will need to like implement all those entry points. You will need to have the calculate the acknowledgement, which, by the way, can be either successful or not, because the packet, as we said, may not ever arrive. And in general, what you're doing is actually moving bytes that are being interpreted by the receiving contract on the other chain. So once the acknowledgement is done, in the sense that, hey, like this contract now has received the IBC message, then it's the acknowledgement message is relayed back to the starting chain, and then basically you have the whole IBC transaction flow into place. So, and again, like if the contract is not if the IBC packet is not relayed properly, then you would have a timeout, basically, where just the IBC transaction reverse back, basically. So in this case, we're seeing a bit some pieces of code of the most important one. Like you're gonna see, there is not a lot of code out there, but like the most important one, I would say, is the contract.rs code. So in this case, basically, like you can see, we have the increment method, where we are basically is the method that we are actually triggering, and once we trigger it, then basically, like we are then performing an IBC execute message. So basically, as we said, like once you are actually triggering the increment method, then the IBC packet. So with basically the content that you got from the increment. So while on the rest, and by the way, this is again like the contract.rs file. So this is where all this code is getting dealt with, and basically you can also like use the query count that is the query that can actually where is the at which number the counter is. So as you can see, for whoever is already comfortable with Rust, is kind of straightforward. So in general, like what is getting done here that is important to understand is that, like, we are triggering the increment method, and this increment method is actually sending an IBC packet. So um, when we go to the IBC.rs instead, here is where we actually are implementing the whole IBC features. So in this case, as we said, like we need to have all our entry points in place. So you can see you have the IBC channel open, you have the IBC channel connect, and you would also need to deal all like the IBC closed and the IBC packet received. So all these entry points are so like let's say this is the main deal when it comes to using IBC with CosmWasm is if we need to get to the main information on like what's the deal here, how should I do it, is basically make sure that you implement the IBC method to deal with channels, and because that's what's gonna allow you to basically increment like perform my IBC connection when you are triggering the packets basically to be sent. So yeah, like also the IBC packet received entry point need to be implemented, of course, as we said before. And we can see that now we have also a function here that is the execute increment function, and here basically what we see is that we have the counter that gets incremented, and basically like we also set an acknowledgement that gets properly updated. So yeah, this is basically in the ibc.rs file, and this allows like basically the contract instance on the receiving chain like to basically update its whole increment, because like the chain would receive the increment message that has been sent as an IBC packet from the starting chain by having triggered the contract on the starting chain, and then the receiving chain receiving the increment message, then it would execute the IBC packet receive function basically, and this is the way that the whole circle would close, and you would have basically implemented the IBC counter like with CosmWasm. So within the ibc.rs file, what you would have, it's yeah, these are the missing entry points that are between those of the 6 that we mentioned so far. So the IBC packet timeout, the IBC packet acknowledgement. So as you can see, like all these entry points, it's are just necessary in order to IBC to work, because you would basically need to handle this whole setting up of channels and acknowledgements of packets, and dealing with what happens if a packet doesn't get acknowledged. Well, the timeout is necessary for that. So so in general, like you can boil down IBC to these 6 entry points that you will need to implement in your smart contract, like in this case in an ibc.rs file. and then yeah, like you would have also another function that would basically need to validate and order and packets, like you, because with IBC you can either get packets in a orderly manner or in a non-orderly manner, then like you, depending on also what is your expectation now to deal with packets, then IBC packets, then you will need to implement, for example, an endpoint like this. And the state of the contract is basically just a map with the channel ID as a key and the counter for that channel as a value. So this is this is quite clean state, right? Like this is the state.rs of the IBC counter, and is just a mapping of the channel ID as the key and the counter of the channel as a value. So and this is what glues everything together, right? Because then in the state, like you would be able to actually make sure that your IBC counter like gets properly executed, and that your in every channel that you may have the counter, then basically your state is coherent. So and by the way, you would also need to have a message.rs because you need to specify what's the message, what does the message look like, right? And in this case specifically, like for the IBC counter, like the messages are in this case it's increment message. So you can see that in the pub enum execute message, like we specified the increment and we put in the channel as a string, and this is what allows the messages to instantiate the contract and as I wrote here, like to execute the increment message on the contract. So and then of course like also send the increment message to the other chain, and then potentially if you want you can query the contract on the other chain to check the IBC message has been properly forwarded, acknowledged, and the logic executed to update the state. So this is mostly it. I wanted to like in general give an overview of like what this is about, and there are a lot of resources I uploaded in the Area52 workshop repository, like some code that you can actually see, and also like there are here a lot of resources. Some of them are I would say like for whoever wants to look into getting into the CosmWasm 20 standard, like that is the standard that we said that it's basically not allowing you to mint tokens, but allow you to move tokens around chains and also like duck them when these tokens are getting transferred. And there are some resources also regarding relayers, because at the moment the two main relayers type that you can spin are basically the IBC Go relayer, and then there is the Hermes relayer. Currently, Archway S2 is enabling two channels, like one for Axelar, one for Osmosis, and we are using the IBC Go relayer. So just for you to know, like this would be the resources that you want to have a look at if you want to spin your own relayers. But again, as I say, like if you want to just create some contract that connect with Axelar or Osmosis, then what you could simply do would be just to use like the relayers that we have. So you would let those relayer forward. So you need to specify like which in the smart contracts, for example, like which channel and stuff like this, like you want to forward messages to. And then there are also some other resources that are interesting for whoever is also a bit more new to the Cosmos ecosystem, and there is very cool in-depth resource on what is IBC. And just for you to know, like understanding IBC is key, right? Because then it's really a protocol on its own. It's like you are understanding like making a Web2 comparison is you are starting to understand how TCP works, and we are in this moment of infrastructural setting up of the new internet. So it's like the more you are comfortable with this standard, then also the easier is gonna be, of course, to use it. So and for CosmWasm, there is the CosmWasm book that you can have a look at in order to get a sense of like how to create CosmWasm smart contract. But again, as I say, like next week, earlier in the week, honestly, this week already could have been updated the content, but we are gonna have the whole CosmWasm documentation. So the plan here is to have everything that developers need in order to build CosmWasm contracts, to have everything on Archway. So basically, you wouldn't need to necessarily leave Archway in order to get some good in-depth CosmWasm knowledge. And for whoever didn't try it out yet, Area52 is amazing. Like, it's really entertaining as a course, and it's really educative. So if you don't know a lot of Rust, you can still use it and learn Rust on the side in order to learn CosmWasm. So it's really an effective way to do it, and it really gives you a lot of sense of what you can do with it. So yeah, I put some links to some resources that are interesting for you guys to see, and that are basically some of these examples that we covered so far. And also, again, as I said, I put some code in the repository of Area52 that you can try it out. And yeah, this is in general it. I wanted to give an overview on what's the deal here, and just provide with resources for you to see what's available, and also like yeah, letting you know that you can the two relayers that we have spin up between Archery and Osmosis in order to perform IBC transactions with CosmWasm contracts. And as I say, like we are, like in general, the whole Cosmos ecosystem, it's you always need to relativize a bit in the sense that it's a newer ecosystem compared to others, and but at the same time has been built with some design consideration that make it way more powerful. At least this is my personal opinion. So, and few things to keep on this note are, for example, the IBC protocol, like the whole inter-blockchain communication standard that, again, as I say, is getting used by other chains and ecosystems that have nothing to do with Cosmos. So this gives a sense of how powerful is it, and also CosmWasm that just like its whole design is amazing because like it really take out burdens from developers in order to handle like re-entrancy attacks, for example, and which again like this is something that exploited was exploited in the DAO, and in general like a lot of like one of the most important attack vector in Solidity based smart contract is this re-entrancy attack. So the whole design around CosmWasm has been taught also like because of this. So this is yeah, this is really powerful. So everything you can do in order to learn about it, then the better. And also like using Rust, it's if you are new to Rust, no issues at all in the sense that like it's very similar to C++ for some way. Like some people consider it the new way of you know using this type of low-level languages, and it's there is a lot of interest around the whole space regarding Rust, and because it really gives you it's kind of a microcontroller over you know the memory of that your code is using. So it really efficiency wise is way more efficient than other languages. Like for example, it's more efficient than Go, and also like because also of this way of handling memory is more secure. So uh, if like even if you don't know a lot about Rust, it's really good to get a sense of what Rust is doing because like I see there is more and more and more interest in having devs that develop on Rust. So like you know developing a smart contract on CosmWasm maybe it's a good way to do it. You know so yeah, this is a bit real. So we're again like the workshop like will be held on a constant basis. The next workshop will be in 2 weeks from now, and I think so. I should check, but yeah, we like the plan is basically to have workshops on a constant basis. So we highly suggest to stay tuned in Discord and follow like what Archway is doing as initiatives because the fun is just starting. So again, like next week we're gonna have some office hours on Wednesday where we support devs that are developing smart contracts for the hackathon that is gonna last 1 month, and yeah, that's where the fun starts. So leave it up to anybody with any questions, like even more general or regarding IBC, CosmWasm, how to use those, and happy to answer to
Thanks, Luca. That was a great presentation. I enjoyed it.
Nice.
Yeah. Although I would also love to see like examples of existing implementations of IBC out in the wild, later.
Yeah, sure. Of the different standards, you mean, right?
Yeah, exactly.
Hey, so question here. Thanks for doing the presentation, by the way. Do you guys have any suggestions for other implementations or other IBC-enabled smart contracts we could try out for ourselves to, better actually get a hand on, get the hang of actually using CosmWasm-enabled, IBC-enabled smart contracts?
So here's the thing, like the recent, like when it comes to documentation around how to use it and implementation and stuff like this, there is some stuff, but like there isn't a lot yet. There really isn't a lot, and this is also the reason I'm saying that we are like the fun is just starting, because you could see like you are really at the beginning of a cutting edge interoperability and smart contract technology. So I've put all the resources I found in the slides, so you can definitely check those implementations out, and I think it's gonna help. But for sure, it's like I'm gonna keep updating like with anything that goes out, and make sure like that everybody in the actual ecosystem know like what are all the current implementation. But again, as I say, like it's we are still in a very initial phase, I would say, because even CosmWasm is relatively new for some things. So and then just get into IBC with CosmWasm, it's like I think this year there's gonna be way more stuff, more resources that you can get your hands on. And for now, what I could find, it's on the slides, and I will definitely update with any resources I have, and for sure we'll keep you guys tuned on anything. So for sure.
Luca, where do we get the slides again?
Yes, so it's in the Area52 workshop repositories. So
Can you post a link on the chat, maybe?
I can.
There we go.
Just
all right.
dropped them.
Yeah, I can send it.
They already got it.
Yeah, it's
Thank
basically the same link of every workshop that we do. So
okay, excellent.
Yeah, if let me know if you cannot find it. If not, we can post it in the chat so everybody.
No, Thread already posted it. Yeah, it's already on there. Cool.
Amazing.
Thank you.
Thank you, Luca, very much. It was really nice, as always.
So yeah, not sure if there are any other questions.
Just one more question about the, you mentioned these office hours on the Wednesdays for the hackathon. I'm going to be joining late. I'm definitely curious to get more involved here, but maybe you can mention some more about that.
Yeah, for sure. So it's a very informal event, in the sense that it's mostly meant for the DevRel team, that is me and Adrian, like to stay available for 1 hour on Wednesdays for the whole, until the hackathon finishes, which is in around 1 month from now, where we basically provide support with to folks that are actually deploying their smart contracts. So for example, in this last office hour on Wednesday, like there was someone who was having issues with the Docker instance on his MacBook M1. So Adrian troubleshooted it, and we went giving some overview on the Archway docs also. So it's more of an interactive session, let's say like this, in the sense that we are basically available to help however we can. So if it's troubleshooting something, then it is, and if not, we support however we can, and even explaining a bit more about Archway, the different developer tools, and everything else. So yeah, there is the event on Discord. I think it's already gone. No, we need to set it up again, but you will see it. It's basically next Wednesday. So around 6 p.m. UTC, if I'm not wrong. So yeah.
Cool. I'm gonna bounce. Thank you, Luca. I appreciate it. See you guys on the next workshop.
Yeah, thanks, guys. Appreciate the work. Take care.
Thank you very much.
See you.
Thanks for joining.